Google Sheets has a great function built in to find the weighted mean using equals average.weighted. All this requires is that you enter a list of values and an associated list of weights. So it's best to set this up with a couple of columns in A and B where we have our outcomes. Those are our X values and our weights I'll call W. Off to the side, I'm going to put some examples of outcomes and weights. First, let's think about a frequency distribution. Outcomes would be measurements, and the weights would be frequencies. In other words, instead of listing repeated measurements again and again, for example, height, we could just say we've got 10 people who are 5'9" and so on. Another example would be grades and weights. I don't know how else to say that. That would be maybe weight percentage weights. But that brings up an interesting point that weights could also be fractions. So you might have, something like you could have alcohol percent, and we could weigh that by the portions. So if you ever see a recipe for a drink, you might have 3 parts of this and 1 part of that. You could weigh your percentages that way and find the overall ABV, alcohol by volume percentage. Another one would be GPA. The outcomes here would be grade points. We don't really think about the terminology really closely of GPA, but that is grade point average. So we think about what is a grade point. Well, that's when you change your letter grade to a number, and it's actually the average grade point per hour. So our weight is credit hours. You might also call it credits per hour if these grade points were thought of as credits and we weigh it by hours. Those are some examples. At the very end, I'll show you how you could create a little spreadsheet that contains your current GPA, current number of hours, and then you can figure out what's going to happen this term to change it. The only other thing I need is my main output, which is weighted mean. There is a way to calculate weighted mean using the product of columns A and B in each row and adding those up. I choose not to do that. Here I'm just trying to find the quickest approach, but I'm going to have another video at the end of this one that will show you how to do that a little bit more step by step for a very specific purpose. Like I said, this is the average weighted function. I'll have my first input in column A. That's A colon A. And then my second input is column B. I choose to just use the entire columns. That way, no matter how big the data set that I put in there is, it will all be calculated, as opposed to if I were to use more restrictive ranges of data, for example, A2 to A10 or something like that. And it is giving me an error right now, and that's because I don't have any data in there yet. So let me just do a quick data set. Let's say I have a large number of people and I ask them all, how many toes do you have? Many people have 10. I'll say 99 people had 10 toes. And then we've got one person with 9 toes. And so that's a way to quickly find that average without having to list out 99 people that over and over and over again. We could do percentage grades and weights. I will quickly just type in a table as an example. Here I've got a distribution of grades. We'll say the grades were a 90, 85, 89, and 92 for 4 different categories, and each of those has an associated weight. An example would be if homework was 25% and I got a 90, maybe quizzes are 30% and I averaged an 85. So there could be an average within each of these outcomes going on as well. And then let's say a midterm and a final. That's an average of 88.8, but it helps you. Let's say you know everything you have up to this point and you don't have that last grade yet. It helps you try out some things to see how different grades would affect that. If you missed something completely, examples like that. The last one I'll do here is the grade points and credit hours. This student had a total of 17 hours or credit hours of class. We've got the grades converted 4.0, 3.0, 2, and 3 with no pluses and minuses there. And that weighted mean comes out perfectly to the 3.0 average, but they could also test this out and see what different grades in different classes would do. The other thing somebody could do is at the very top here, just put a row with the overall GPA so far. Let's say right now I have a 3.98 GPA over 68 credit hours up to this point. And this quarter, I want to make sure I maintain at least a 3.9. Again, it's still looking at those entire columns. We can see that these grades are not going to be good enough for that 3.9. We can try some things out, make them all a 4, see where we're at, and now start dropping down. This is something that helped a friend of mine who was trying to get into PA school. He needed a 3.8 GPA and he was just shy, and he wanted to know if one more credit would do it. He was trying to take a 5 credit course and bring it up just a little bit. I think he was at a 3.77 or something like that. Must have been a 3.79. And he wanted to know if one more A could do it. And that's a way that he was able to check using his current number of credit hours. Check out the next video that I've got where I'll look at a more in-depth approach and we'll talk about discrete probability distributions.